So in this short video I'm going to show you how to use coding to calculate the standard deviation and mean from a frequency table. So I'll just put my frequencies in quickly and then we can get started. So I've got my x values, I've got my frequencies, and we're going to produce a y value which will make the y value adjustment on x will be smaller, easier to use, and we'll calculate the mean and standard deviation of y and then we'll code it back to x. So y equals x take away 5 divided by 10. If I take my first value of x, 55, take 5, is 50 divided by 10 is 5. 65, take away 5 is 60, divided by 10 is 6. And you'll see that I've arranged these, let me quickly correct that one, so that we come out with these small numbers. So I then, so just check on the last one, 95 take away 5, 90 divided by 10 is 9. So with the smaller numbers I can get Fy as 20, 9 6s are 54, 10 7s are 70, 3 8s are 24, and 2 9s are 18. Now I can straight away find the mean of y. So the mean of y will be the sum of Fy divided by the sum of the frequencies. So frequencies were 4, 9, 13 and 10 is 23, 23, 26, 28. So I'll be dividing by 28. My sum of Fy, 74 and 70, 144, 168, 176, 186. So I have my mean as 186 over 28. I'll quickly calculate that. So 186, you can hear me using my calculator, 28 equals 6.642. So equals 6.642. Now that's probably 28. We'll take that and we'll round the rest off and that will still give us a decent degree of accuracy. Now to get us back to the mean of x, then I literally have to rearrange this to make x the subject. So we've got the mean of y, so, but I'll rearrange it first. So x, it's fairly simple to do. X bar is going to equal 10 y bar plus 5. So we've worked out y bar, so x bar will equal 10 times 6.6428 plus 5, and that's going to give me 66.43, 66.43, I've rounded off there, plus 5, 66 and 5, 71, so we've got 70 x bar, 71.43, and if I want it to one decimal place, 71.4 to one decimal place. And if we have a look in it, it looks about right. It is reasonably symmetrical, slightly more numbers below 75 than above, and we've got 71.4, so I'm very happy that that's all been done correctly. It makes sense. Now to carry on, we need to have our Fy squared, so we have our f, we've got our y, so we need our y times our Fy to get Fy squared, so 520s are 100, so it's very important you multiply the right two columns. Where mistakes are made, it's usually multiplying this first column here. So 654s are 324, and you can see the numbers are easy enough for me to do in my head, although in your exam you can do this with a calculator. 820s are 160, that's 192, and then 9 18s, 9 9s, 81, that's 162. Now I will use the calculator to do this bit. I can't pause the video, so bear with me for a second while I add things up. So we've got 424 plus 490 plus 162 plus 192. Okay, so 1268. So I've got a 1268 total there. I'll just put in that 186 which I worked out earlier there. So the standard deviation of y, is going to equal the square root of the sum of Fy squared. I'll write this all in so you can see where it's coming from, minus the sum of f minus y bar squared. So this gives me the square root of 1268 divided by the sum of f, which we made as 28 earlier, 28, minus the mean of y. The mean of y was 6.6428, 6.6428 squared. Now, I'll try and get this quickly with my calculator. So the square root of 1268 divided by 28 and minus, open up my brackets, so I knew I'd have a bit of trouble with this. I think rather than waste a lot of time doing this, I'm assuming you can put that through your calculator. So we'll call that standard deviation of y. Now, standard deviation of y, and to get back from our standard deviation of y to x, we simply have to times it, this answer, so whatever we get there, we times that by 10. We needn't worry about the subtract 5, it doesn't make any difference to the standard deviation, so we simply times it by the thing that we multiplied through by. So standard deviation of y times 10 will equal standard deviation of x. Now I will try and do this on my calculator. One will go with this. So 1268. Okay, so we do that. So I've got that bit. No, that's not right. So so we want square root, open brackets, 1268 divided by 28, close brackets, minus in brackets 6.64, 6.6428, close brackets. This has got to be squared. It's not easy how to do this, square it. Okay, let's see what we get there. I'm not entirely sure that's right, but let's suppose it is. So equals 1 point. So what I've got here, the standard deviation of y, I got 1.0765. So if we times that by 10, okay, just down here, so 1.0765 times 10 will give me the standard deviation of x, which gives me 10.8 to one decimal place. In actual fact, I think I have pushed that through the calculator correctly. The whole distribution from 55 to 95 is a gap of 40. I'd say that's probably about right. So we'll go with that. Important things to remember is how to code. Make sure you multiply the... Alright, so to use the coding, that's fairly simple. Finding f times y is simple. Be careful on fy squared. Make sure it's y times fy to get fy squared. Make sure you substitute it into your formula and you know how your calculator works. And on the adjustment for y bar, you need to completely reverse what was done. The adjustment for the standard deviation is to simply multiply it by what you divided in the coding. And that's how we do standard deviation alone from a frequency table using coding.